In this lecture, we're going to give a brief overview to Perl, both its history and its variables, data types, and operators. And I'm just going to be giving kind of a overview and guide to the Perl notes and expect you to delve into them more deeply, both on your own and in the homework assignments. So Perl was conceived by Larry Wall in the late 1980s as a way to help him extract data from files and to create reports. And he basically was trying to combine a number of different small languages such as sed, grep, awk, along with the C language in order to get a more powerful tool for extracting information from files. Basically, he was trying to combine the regular expression features of sed, grep, and awk with the general control constructs of the C language. Its portability quickly made it a favorite of Unix administrators, and as new areas opened up, modules would often be developed to handle these areas, such as a CGI model for the web, a graphics model for doing graphical interfaces, and however, more specialized languages such as Python, Tcl, and PHP often followed that filled the niche better than Perl. So Perl is often a trailblazer. One of the first people experiment in a new area with it, but then a new scripting language emerges to fill that niche area. So Perl is still primarily used for data extraction from files. It's currently undergoing a major transformation from Perl version 5 to Perl version 6. Perl 6 has a formal specification, whereas Perl 5 had an informal specification. Perl 5 is still the predominant dialect used, and it's the one we'll cover in this course. Perl 6 is not yet widely adopted. It's been around since 2000, and while it will probably become more widely adopted in the future, it still does not have a wide audience. So why is Perl so popular, especially among Unix system administrators? Well, it provided a nice way, a platform-independent way to get access to the system facilities, like changing a directory, creating files, deleting files, etc. And its regular expression syntax gave you a powerful way to manipulate the file system. It also was a very powerful feature-rich language which allowed you to write programs very concisely. This also is what led to its disadvantages. The feature richness means that you can sometimes do a task a half dozen different ways, and that can lead to indecision as you mull over the best way to do it. It also can make it hard for someone else to read your code because they may know 2 of the 6 ways to do it, but you selected one of the 4 ways that they don't. And finally, the features designed to make it concise can also make it hard for others to read your code. It's kind of like trying to read someone else's shorthand. In fact, Perl has often been called a write once, read never language. So I'm now going to start taking you through the notes kind of in a nice overview way. And again, I'm just trying to give you a quick guide to the notes. Expect you to go through them more at both your leisure and as you get into them in the homework assignment. So if you're working on a Unix-based system, you can invoke Perl from the command line using the Perl command, the name of your script, and command line arguments. Typically the scripts end with .pl. You can also put this line at the top of your Perl file and then change it to an executable version using the chmod command in Unix and execute it. However, this is kind of specific to Unix and is unlikely to work on a Windows platform, especially because it's almost certain that the Perl executable will not be in the directory shown here. So comments in Perl are a little different than in C. They use a hash mark, and they can either start a line or end terminate a line, but anything after a hash mark is a comment. Also, notice the semicolon. All statements in Perl are terminated with semicolons, just like in C. Okay, so moving into variables, there's 4 basic variable types in Perl. There's scalar variables, which are for things like integers, floating point numbers, strings, and characters. There's arrays in the traditional sense that you know about them, but also they function much like a list data structure. There's hash tables, and there's references which function like pointer variables. So the variables don't have to be declared in Perl. We'll find out that it often is useful to do so. The variables are dynamically typed, although you denote scalars by prefixing them with a $sign, arrays by prefixing the variable name with an @ sign, and hashes by prefixing the name with a % sign. So we'll start with scalar variables, and the data types are the same ones you find in a normal language: integers, floating point numbers, strings, chars. It does not have a Bool data type. Like C, it uses 0 and 1, but it also has some other values that we'll get to in a moment. First of all, notice that scalar values, their names are prefixed with a $sign, and notice it's just like the syntax is very C-like. There's a number of data types that you need to be familiar with. Since Perl was designed as a string manipulation language, it has a lot of features associated with its strings. In fact, there are 3 ways to specify a string. There is single quotes, double quotes, which is what you see right here, and then back quotes, which actually execute a command such as ls in Unix, and then it returns the result of that command as a string. The single quotes just cause a string to be literally produced the way that you type it in. So for example, if you were to say here with I love \n cookies, and you did it in single quotes, the \n would not be interpreted as a new line character. It would be literally just a \n. If you wanted it to be interpreted as a new line character, you would have to put the string in double quotes. Also, you can do something called variable interpolation, okay, right here, with doubly quoted strings. And what that means is that you can put a variable inside a string, and the value of that variable will replace the variable's name. So here, the value of my dog is Collie, and $dog gets replaced with Collie, so it becomes I love my Collie smile. Here's another example right here with that interpolation. That's a simpler example. You don't have to put the name of the variable in curly braces. The reason for doing it here was to distinguish dog from the colon or the apostrophe s afterwards. It let it know where the variable name ended. It's also possible to interpolate arrays into a string, but not hash tables. There's a number of string manipulation functions that I encourage you to explore on your own. We will not talk about them in this video. As I said, Perl does not have a formal type for Booleans. However, it does have truth values, and it does treat several values as false. Just like C, 0 is false, but also anything that casts to a string containing a single 0, such as the string 0, is considered false. Notice that the string 00 does not cast to a string containing a single zero. The empty string is viewed as false, and a special value undef is treated as false. So if a variable is used before it is assigned a value, it is given the value undef. And you can test whether a variable has been defined by using the defined function. If the variable is associated with a value, defined returns 1, otherwise it returns undef. So if any value other than the 4 that you see here are considered true values. I'm going to skip the I/O for a moment, and we're going to move on into a discussion of array variables. And arrays can be treated just like arrays, but they're probably best thought of as ordered lists. So an ordered list is in Perl created using a pair of parentheses and a comma-separated list of values. So here I'm assigning a list of 4 strings to the array dogs, which as you see is prefixed with an @ sign. And now you can access the elements of dogs using the normal subscript mechanism that you associate with arrays. Arrays use zero-based indexing, so the first element is at position 0. Now notice here we can use a negative subscript. Negative subscripts start counting from the back of the array. So here -1 says to return the last element in the array. -2 would say return the second to last element, and so on. Okay. Here you can see another example where we're using actually a string. We are taking the ls command, which lists the contents of a directory, and that returns a list of strings which will now be broken up and assigned to the elements of @dir, and now you could get at them through the subscripts 0, 1, 2, 3, and so forth. A helpful feature of arrays that we'll find when we get to functions is an ability to unpack them. So if you put a series of variables or a list of variables on the left-hand side of an assignment statement and an array on the right-hand side, then the first elements of the array will be assigned to the elements in the list. So here we have the numbers 2, 4, 6, 9 right here. And when we set A, B, and C equal to nums, 2, 4, and 6 get assigned to A, B, and C respectively. I'll let you read about the other cases on your own. But this unpacking is going to allow us to return multiple values from a function by returning an array of values and then unpacking them into a list of scalars. Okay. Also handy in Perl is the ability to treat an array as though it were either a stack using pop and push, which remove and add items to the end of an array, and shift and unshift, which treat an array like a FIFO queue and remove and add elements to the front of the array. The next type of variable or data type in Perl are hash tables, frequently called associative arrays or dictionaries. So the idea is a dictionary, you are able to look up words based on a key, which is the word, and then it has a definition. Same idea with hash tables. So you have a list of keys, key value pairs, and you can look up a value by providing its key. So in Perl, your hash tables variables are prefixed with a %, and you can create them using a list, and now each pair is a key value pair. So here black is the key value, Labrador is the value, red is the key, setter is the value, white is the key, poodle is the value. Since that's not particularly readable, you can also add the greater than equal sign as a way to delimit your pairs. So this is an easier way to read this assignment. It says black is the key for Labrador, red is the key for setter, etc. And notice you didn't have to use quotes for the keys here. To access the individual elements of a hash, you use curly braces rather than the brackets for an array. So it looks like an array, but you use curly braces instead. And notice you don't have to use the double quotes for your strings. And you can interpolate the individual elements of a hash table into a string. You can't interpolate the entire hash into the string. If we go back to arrays, you can see that we can interpolate an entire array into a text string, and it will print the contents of the array separated by spaces. That's not true for a hash, but you can interpolate a single element. And again, Perl provides a number of handy operations. I encourage you to look at them on your own time. Finally, Perl provides references which act much like a pointer in C. The operator is a backslash rather than an ampersand, and it stores an address in a scalar variable. So a reference variable is a scalar variable. You then dereference the scalar, that reference, by using the appropriate sign. So here I assigned a scalar reference, or a reference to a scalar variable, to B. So to dereference it, I put a $sign in front of it. So $sign B sets $A to 20. Here I create an array of numbers, take the address of it and store it in B. So now when I want to get a scalar element out of B, I dereference it with a $sign. But when I want to print, or when I want to push an element onto the back of nums, I actually dereference the scalar using an @ sign because I want to treat it as an array in this case. So the way you dereference a reference variable determines how the underlying variable or memory location is treated as a scalar, an array, or a hash. And the reason we need to use references in Perl is both for passing arrays and hashes to functions. We'll see when we get to functions in the next lecture that you can't easily pass an array or a hash to a function unless you use a reference to the array or the hash. And the second reason we need references is to create records. So Perl does not have an actual record construct, and over the years programmers have used hashes to represent records. But the obvious way of creating a record using a hash doesn't work in practice. So here's the obvious way. Create an array. So we want to create an array of records. So we create our array. Now we create a named hash called B with Brad and age as the key, and we try pushing onto the array A, B. Okay, now we create a second quote record, assign it to B, called Aaron and age, and now we push that record onto A. And you'd think that this creates two hash tables that are now associated with the array A, and you would be wrong. What you have instead is a list of 8 elements. Okay? The first 4 elements are from the first hash table you created, and the remaining 4 elements are the second. So you really have a scalar array, or array of 8 scalar elements, exactly what you don't want. So what you have to do is you have to create a reference to your hash tables, and the way you do it is you create what's called an anonymous hash table, and you do that by using curly braces rather than using parentheses for your list. So here is a curly brace or a comma separated list of key value pairs in curly braces. This creates an anonymous hash table and returns a reference to it that we store in newrec. And now we could push this reference onto an array. So here's an example where we're simply reading records with names and ages from a file and storing them into an array. So we define a new array, and we'll see this idiom in a moment. This is how, just take for my word for a moment, that this reads a line from a file, and that this command right here, what it does is splits that line into a series of words and assigns it to the array data. So data is a list of words. Now I create my hash table, my anonymous hash table, and associate the first word in data with name and the second word in data with age. And then I push the reference onto an employee records. And when I'm done, I will have an array with some number of scalar references. Each reference is to one of those anonymous hash tables. So it turns out we can also create anonymous arrays where the return value is a reference to that anonymous object. And we do that by using a comma separated list that's enclosed in brackets rather than parentheses. So this is a lot like using malloc or new, so like using malloc in C and new in C++, and creating a pointer to a dynamic piece of memory. So to recap, here's the recap. If you want to create a named array or hash table, create it using a list between parentheses. If you want an anonymous array, create it using a list that's between brackets. And if you want an anonymous hash table, create it using a list that's between curly braces. And you'll get a reference to your anonymous objects. Okay, so we've reviewed now the 4 types of variables in Perl: scalar variables, array variables, hash tables or hash variables, and reference variables. Let's quickly go through the operators. The arithmetic operators, just like you have in C, and additionally you have ** for exponentiation. So over here, if you set $f equal 5 ** 3, that will give you 125. So arithmetic operators the same. The comparison operators are the same as in C for comparing numbers. Just like C, you cannot compare strings using these operators. Instead, Perl provides a different set of operators for comparing strings. So string comparison is different than numeric comparison in Perl. If you try to compare a value with undef, undef will be cast to the value 0. And finally, just quickly with I/O, we'll go back up here. We'll cover I/O in more detail in the next lecture, but here we're just going to talk about reading input from standard in and writing output to standard out. So if you want to read input from standard in, you do it by using the so-called diamond operator. Okay, so this is the so-called diamond operator. It looks like a diamond. It's a less than sign followed by a greater than sign, and you put standard in all capital letters between it, and when you say something like $line equals standard in, it will read an entire line of input. You can also omit standard in, as I did right here, if and only if you do not use command line arguments. If you use command line arguments, what's highlighted in blue here will fail miserably, because then it will be reading from, it will treat each of your command line arguments as a file, and it will try to open each file in turn and read from lines from the file. So only use this idiom if you don't have command line arguments. If you expect your script to be used in the future, please use the standard in notation, because someone could change your script to use command line arguments and it would mess up your script. So to be safe, put standard in between the braces. Only if you're writing a quick and dirty script should you write it with an empty diamond. Now, it reads the entire line. If you want, including the new line character. To get rid of the new line character, you can say chomp, and that will remove a new line character if it exists. Or you can combine the two. This is a Perl idiom like this. It will read the line into $line and remove the new line character. Finally, if you want to print, there's two versions of print. A simple print, which will print a string to the screen without a new line character. And you can provide a comma-separated list of strings to print out and variables. So $X, the value, will be printed. Spaces are put between the fields, and notice the new line character at the end forces a new line to be printed. And then printf is available for more sophisticated formatting. It works just like the printf command in C. Finally, if you do use command line arguments, going back up to the very top here where we said you could use command line arguments, the way to access them is through argv. So argv, at argv is an array that will give you access to the command line arguments. And again, remember the conventional suffix for a Perl file is .pl. In the next lecture, we will be going through Perl functions, Perl's interaction with the file system, and Perl's regular expressions.